how the UK internet actually works. When people say they are using the internet, what they usually mean is that they are using a service, a website, an app, a streaming platform, online banking, or email. What sits underneath those services is a complex physical and logical system that moves data across the country and across borders. This video explains how the internet actually works in the UK, not at a protocol textbook level, but at an infrastructure and operational level. How data moves from a device in a home or office through networks, exchanges, and data centers and back again. Who owns which parts, how they interconnect, and where the real constraints sit. Starting at the device. Every internet connection starts at an end device, a phone, laptop, tablet, television, or industrial system. That device connects to a local access network, either fixed or mobile. In a typical UK household with broadband, the device connects to a router, usually supplied by an internet service provider. That router connects to the access network via fibre, copper, or cable. In most cases, that physical line is owned by Openreach. The retail provider manages the service, billing and customer support, but the physical path from the premises to the local exchange is shared infrastructure. This distinction matters. When there is congestion, a line fault, or a regional outage, responsibility is split between multiple organisations. Local access and aggregation. From the premises, traffic travels to a local exchange or aggregation point. Historically, this was a telephone exchange. Today, it is more likely a fibre aggregation node. Openreach operates thousands of such sites across the UK. Traffic from many premises is combined and forwarded into regional and national core networks. Virgin Media O2 follows a different architecture. Its cable network aggregates traffic through head-ends before forwarding it into core infrastructure. Alternative fibre providers use a mix of local and regional aggregation depending on scale. At this stage, traffic is still within the access provider's network. Performance here is influenced by line quality, contention ratios, and local capacity planning. Core networks and carriers. From aggregation points, traffic enters core networks operated by large carriers. These are high-capacity fibre networks that move data between cities, regions, and major facilities. In the UK, core network operators include BT, Vodafone, Virgin Media O2, and specialist carriers such as Colt, GTT, and Tata Communications. These networks run at very high speeds and are engineered for resilience. Core networks connect cities like London, Manchester, Birmingham, Leeds, and Bristol. They also connect to major data center campuses and international gateways. Routing decisions at this level determine how traffic flows across the country. These decisions are influenced by capacity, cost, redundancy, and commercial agreements. Internet service providers and routing. Retail internet service providers operate their own networks on top of or alongside these core carriers. Large ISPs such as BT, Sky, TalkTalk, and Vodafone maintain national networks that interconnect with carriers, content providers, and exchanges. Routing on the internet is not centrally controlled. It relies on protocols that allow networks to announce which destinations they can reach. These announcements are influenced by policy, commercial agreements, and operational constraints. As a result, data does not always take the geographically shortest path. It takes the path that is available, permitted, and cost-effective at that moment. Internet exchange points. A critical part of how the UK internet works is the use of internet exchange points. The London Internet Exchange, known as LINX, is one of the largest in the world. It operates multiple facilities across London and other UK cities. Networks connect to links to exchange traffic directly with each other. At an exchange, traffic destined for another connected network can be handed over directly rather than sent through a third party. This reduces latency, cost, and congestion. Many UK ISPs, content providers, cloud platforms, and international carriers connect at links. Other exchanges operate in Manchester, Leeds, and elsewhere. Exchange points are neutral facilities. They do not route traffic themselves, but provide the physical and logical environment for networks to interconnect. Content delivery networks. Much of the content people access does not come directly from the original service provider. Large platforms such as Google, Netflix, Amazon, and Meta operate content delivery networks. These place servers close to users, often inside ISP networks or at major exchanges. When someone streams a video or loads a popular website, the data is likely served from a local cache rather than a distant data center. This reduces load on core networks and improves performance. In the UK, content delivery infrastructure is deeply embedded in the internet ecosystem. Many ISPs host caching servers within their own facilities. Data centers and service hosting. When traffic is not served from a cache, it travels to a data center. UK data centers host web servers, application platforms, databases, and back-end systems. These facilities are connected to multiple carriers and exchanges to ensure redundancy. Major cloud providers operate large campuses around London and the South East. Enterprises and public sector organizations use both cloud and private data centers. A single online service may involve multiple data centers. A web front-end might be hosted in one location, databases in another, and backup systems elsewhere. The Internet functions as a fabric connecting these facilities together. Mobile Internet specifics. Mobile Internet follows a similar pattern with additional layers. A mobile device connects to a radio base station operated by a mobile network operator. That base station connects via fiber backhaul to a core mobile network. The core network handles authentication, mobility management, and traffic routing. From there, traffic enters the same Internet core and exchange infrastructure used by fixed networks. Mobile networks also rely on international roaming agreements, signaling systems, and spectrum coordination. These add complexity and potential points of failure. Performance is influenced by radio conditions, network load, and backhaul capacity. International connectivity. Much UK internet traffic crosses borders. Subsea cables connect the UK to Europe, North America, and beyond. These cables land at specific coastal sites and feed into national core networks. Financial services, cloud platforms, software updates, and communications platforms rely heavily on transatlantic connectivity. Latency and reliability on these routes are critical. International routing decisions are influenced by cost, capacity, and resilience. Traffic may be rerouted dynamically in response to faults or congestion. Resilience and redundancy. The Internet is designed to tolerate failure. Multiple physical paths, carriers, and facilities exist so that traffic can be rerouted if part of the network fails. This is not perfect, but it provides a degree of resilience. In the UK, critical facilities such as exchanges, data centers, and cable landing sites are designed with redundancy in power, cooling, and connectivity. Despite this, failures still occur. Fiber cuts, power outages, software bugs, and misconfigurations can disrupt service. Regulation and oversight. Internet infrastructure in the UK operates within a regulatory framework. Ofcom regulates communications networks, including broadband and mobile services. It sets coverage obligations, manages spectrum, and enforces competition rules. Data protection law influences how traffic is handled and logged. Security guidance from the National Cybersecurity Centre shapes operational practices. While the Internet itself is decentralized, the infrastructure that supports it is governed and monitored. Performance and congestion. Internet performance depends on capacity planning. ISPs and carriers must balance investment against demand. Peak usage periods, such as evenings, place higher load on access networks and backhaul links. Congestion can occur at multiple points: local access lines, aggregation nodes, core links, or peering points. Identifying and resolving congestion requires coordination between multiple organizations. Performance issues are often not caused by a single failure but by cumulative load. Why the Internet behaves the way it does. Many user frustrations make sense once the infrastructure is understood. Slow speeds, regional outages, variable latency, and service interruptions are often the result of shared infrastructure, commercial boundaries, and risk management decisions. The Internet is not a single network but a network of networks. Cooperation is voluntary, governed by agreements rather than central authority. Closing perspective. The UK internet works because thousands of independent systems cooperate closely enough to move data reliably most of the time. It is built on physical infrastructure, commercial agreements, technical standards, and operational discipline. It is resilient but not infallible. Understanding how the UK internet actually works helps explain its strengths, its limits, and why it changes gradually rather than dramatically. In the next video, we will look at how cloud platforms and data centers fit into this picture, and why so much of the internet now depends on a small number of large infrastructure providers.